So we are to check on how to find the equation of a tangent and also finding the average gradient. There is a difference between average gradient and a gradient, the one that we find by finding a derivative, right? So this is the gradient. This is the gradient, and then this one, change in y over change in x. This one, we call it the average gradient. We use 2 points. It's y2, y1, x2, x1. So here we are going to look on how to find the average gradient. Right. You will be given the points. Sometimes you might be given the points, the values of x and an equation. So in that situation, for instance, let's say you are being given that, or you are being given the equation g at x is equal to 2x squared minus 3x. And then you are being asked to find the equation of a tangent at x is equal to 2 and x is equal to negative 3. Right? You are being given the x values and y. This is y. This is y. So y is equal to 2x squared minus 3x. So you've got 2 values of x. You are going to use this one as your x1 and this as your x2. You start substituting by the first value of x in the given equation to find y1. So this is your y. So to find y1, you are going to substitute the values of x there. It's 2 into 2 all squared minus 3 times 2. In the place of x, you put 2 to find y1. So y1 will be equal to, this is 4 times 2, which is 8 minus 6, and then the answer will be equal to 2. That is y1. And then y2, you use the same equation. This is your y. You use the same equation. This will be 2 into, and then now you are going to use your x2 because you are looking for y2. It's negative 3 squared minus 3 times negative 3. Wherever there is x, you put negative 3. Right. 27. This is 9 times 2, which is 18. Negative by negative is positive. 3 times that would give us 9. So the answer here will be 27. Therefore, let's find now the average gradient. The formula for the average gradient is changing y, y2 minus y1 over x2 minus x1. Right, you are going to substitute into the formula with the corresponding values. When I'm saying the corresponding values, you've got x1, so you are going to use y1. x2, y2. So your y2 here in this case, you've got 27 minus your y1 is 2 over x2 is minus 3 minus your x1 is minus that. So 27 minus 2, that will be 25 over minus 5. Therefore, our average gradient will be negative 5. The average gradient here is negative 5. Average gradient is given by y2 minus y1 over x2 minus x1. Let's move to the next example.
Given f at x equal to 2x squared minus 6x.
And we are being given 2x squared
minus 6x.
Minus 6x.
Calculate number 1.
Right, we are to calculate.
So number 1, the average gradient between the points x is equal to 2 and x is equal
Right, that's average gradient. Between the points. X is equal to
2 and x is equal to 4.
And x equals
5. Number 2,
right. Here you are being asked, that's our first question. You are being asked to calculate the average gradient. The average gradient between the points where x is equal to 2 and where x is equal to 5. So our y is given by f at x equals 2x squared minus 6x. Right. For us to find the average gradient, we need y2, y1, x2, x1. So let us find the value of y1 using the remainder theorem. So this is f at, we substitute by 2 in place of x. So let's check what is the remainder if x is equal to 2. This is 2 times 4, which is 8. 8 minus 12, that will be negative 4. So, therefore, your y1 is equal to negative 4. Let us now find y2. Again, we are going to use factor theorem, remainder theorem. It's f at 2. 2 times 5, that 5 all squared minus 6 times 5. So this is 25 times 2, which is 50. 50 minus 30. Our answer is 20. So this means that our y2 will be equal to 20. Now let's find the average gradient. Average gradient is given by changing y over changing x. So our y2 is given by 20. y1 is given by negative 4. It's y2 minus y1. So we put that in brackets. Divided. Our x2. It's 5 minus 2. Negative by negative, it's positive, therefore it gives us 24 over 3, which is 8. So that's our average gradient. Let's try to move to the next question.
Number 2, we say calculate the gradient of the tangent to the curve where x is equal to 3.
Calculate
the gradient of the tangent to the curve.
to the curve.
Yes. Where x is equal to 3.
So we are to find,
the gradient is underlined.
or we are to find the gradient, right? So you are being given the value of x. We are to find the gradient, not average gradient. So here, remember that there is a difference between the average gradient and the gradient, as I've mentioned earlier on. So for the average gradient, we are being given the equation f at x equals to x squared minus 6x. That's our equation. So we are to find the gradient of a tangent to this curve. Remember that to find the gradient of a tangent, we differentiate. So we need to differentiate the given equation. We need to differentiate that. So it's 2 times 2, which is 4x, because you are going to subtract 1 of that, and then minus 1 times 6, that is 6. So this is our gradient. And then you are being given a point. So you are to find the gradient of a tangent at a given point. Our point, the given point, is where x is equal to 3. This means that you are to find the gradient where x is equal to 3. Find the gradient where x is equal to 3. This is a given point. So it's 4 times 3 minus 6. This is 12 minus 6, which is 6. So the gradient of a tangent to this curve is equal to 6 if x is equal to 3.
The next question. Given f at x equal to x cubed.
So let's look at the next question. Given f at x
equal to x cubed minus 3x squared plus 4.
minus 3x squared plus 4.
Calculate the gradient of the tangent to the curve of f at the point 3 is to 4. So calculate the gradient of the tangent to the curve f. At the point 3 is to 4, and use it to find the equation of this tangent.
At the point
3 is to 4.
3 is to 4.
And we use it to find the equation of this tangent.
Right. You are going to use the same gradient to find the equation of a tangent. Right. Calculate the gradient of a tangent to the curve at the point. So as we are saying at, that means 3:4 is a point of contact. Is a point of contact. So when you have a tangent like that, remember that a tangent is a line that touches a curve at one point. For instance, if you have a tangent like that, and then you are being given a point, at the point, that means at represents that point, x1, y1, according to the equation of a tangent. The equation of a tangent is given by y minus y1 equals m into x minus x1. So m, this is the gradient. That's the gradient. This is the equation of a tangent. So x1 is to y1. This is the point of contact. This is the point of contact. So that's the point of contact, where we used to say at. That's the point of contact. The point of contact. So you are to find the gradient of a tangent at a given point again, and then after you find the equation of a tangent. Right, let's see on how to do this one. Right, our given equation or function is f at x equals x cubed minus 3x squared plus 4. So we want to find the gradient of a tangent at that point. So here, let's find the gradient. Remember that the gradient is this one, m. So this will be, when you start deriving there, it will be 3x squared minus 2 times that, that's 6x. That's the gradient. But then we are being given the point. So we are going to use the given point. We are to find the gradient at a given point. Our point there. We are to find the gradient where x is equal to 3. Right. This is 9 times 3, which is 27. Minus 18. 27 minus 18. That would be 9. So this is our gradient to the curve. And then we are to find, remember that in our equation we've got the gradient y1, x1. For this equation to be in a standard form, it has to look like y equals mx plus c. And then let's now find the equation. It's y minus y1 equals m into x minus x1. So y minus y1, our given point there, it's 4. The gradient is 9 minus our x1 is 3. So we need to solve the brackets. It's y minus 4. 9 times that, it's 9x minus this and that, it's 27. and then we are to transpose 4. Y will be equal to 9x minus, if we transpose 4 to that side, we are going to get 23. So the equation of a tangent to the curve of f will be given like that, will be given by this. So it's y equals mx plus c. This is the standard form of the equation of a tangent.
Next question. If gxx is equal to 3x squared minus 2x plus 5, then calculate the x coordinate of the point where the gradient of the tangent is half.
Calculate the x coordinate
of the point where the gradient of the tangent to the curve is equal to 1/2.
where the gradient
Of the tangent to the
of
curve.
the tangent to the curve
Of the tangent is 1/2.
Right. Here you are to find the point. Remember that the point must be in a form of x is to y. That's a point. So you are to find the coordinates. You are being given the gradient. Right, let's see on how to do this one. The given curve is g at x equals 3x squared minus 2x plus 5. Right. When you look on this example here, I've made an example of that curve with a straight line there, which is our tangent. At this point, the tangent and the curve, they intersect at that point, which means they are equal with everything. The roots are equal, also the gradient is the same at that point. So, which means here you can find the gradient of this. Let's find the gradient. This will be 6x minus 2. That's the gradient of a tangent to this curve. But we are being given the gradient of a tangent to this curve. So we are going to equate this gradient of a tangent with the given gradient. So therefore, the gradient of a tangent is equal to 1/2. That's given. 6x minus 2 will be equal to 1/2. And then we are to solve here. 6x will be equal to 1/2 plus 2. It's 1/2 plus 2, which is 5/2. 1/2 plus 2. This is over 1. LCD is 2. 2 divided by 2. And then this will be 1 plus 2 divided by 1. It's 2 times 2. That's 4. Therefore, we are going to find 6x equals 5/2. And then we divide by 6 because we are to find the value of x. we are going to divide by 6. Let us just do it like this. 1/6 on both sides. 1/6. Right? Our x will be equal to 5/2 times that. That will be 12. So our x is 5/12. Let us now find y. So in order for us to find y, remember, x is to y. So we've got the value of x. Let us see now, what will it be the value of y if x is equal to 5/12? So our y is given by g at x equals 3x squared minus 2x plus 5. This is our y. So let us find the value of y if x is equal to 5/12. So we are to find g at 5/12. That's a remainder theorem. It's 3 into 5/12 squared minus 2 in place of x again, you put 5/12 plus 5, and then the answer will be equal to
75/16.
that's 75/16. Therefore, the point now, we are to find the point. It must be in the form of x is to y. So our point is 5/12 is to 75/16. So that's how to find the point if you are being given the gradient only. You are being given the gradient and the equation. Right? The question was asking us to find the point. The last example.
Determine the equation of the tangent to the graph of y equal to f of x equal to x squared minus 3x at the point a is 4:4. Determine the equation of the tangent to the graph of y is equal to f of x equal to x squared minus 3x at the point a is to 4. Determine the equation of the tangent to the graph of y is equal to f of x is equal to x squared minus 3x minus 3x at the point a at the point a is 4.
Right, you are to find the equation of a tangent to this curve at a given point. Again, you do the same. You will have to write your equation, which is f of x is equal to x squared minus 3x, and then you are to find the gradient of a tangent at a given point. So we derive, this would be 2x minus 3, and then the given value of x is 4, 2 times 4 minus 3. So it's 8 minus 3, which is 5. you've got the value of y, so this is the gradient of a tangent. It's simple, you use the equation again, y minus y1 equals m into x minus x1, and then we substitute by the given point. Our y1, it's 4, the gradient is 5 minus 4. Y minus 4 is equal to 5x minus 20, and then we transpose 4. Y will be equal to 5x minus 16. That would be our equation of a tangent. So that's how to find the equation of a tangent, and also finding the average gradient. So we are going to stop here, and then when we continue, we are going to move on and check on how to sketch now a graph of a cubic function. Let's stop here.